All right, what happens if we have something a bit more complicated like this? What do? Well, what we do is we multiply by the conjugate. We spell that word conjugate. For example, in this problem here, we have 4 minus root 3. The conjugate is going to be exactly the same thing, but with the opposite sign. So when we multiply by the conjugate, we have to multiply it by 1, meaning that I have to have both the same thing in the numerator and the denominator. All right, let's go ahead and multiply this. 6 times 4 is 24. We're doing FOIL. That's my F. My outer is going to be 6 times root 3, which is a 6 root 3. That's my O. My inner is going to be root 3 times 4, which is a 4 root 3. And my last is going to be root 3 times root 3. Well, square root of 3 times the square root of 3 is the square root of 9, which is 3. Or you can think of that as the square root of 3 squared, where the squared and the square root cancel. So I just have plus 3. All right, we're going to do the same exact thing, but we're going to do it with the denominator now. So 4 times 4 is 16. That was my F. My outer is going to be a 4 root 3. My inner is actually going to be a minus 4 root 3. And then my last will be a negative root 3 times a positive root 3. So that's going to be we know the squared and the square root cancel, and we're just left with a negative 3. You should notice that in the denominator, our square roots cancel, which is exactly what we want when we're rationalizing the denominator by multiplying by the conjugate. And this will always happen, and the reason why is because by forcing your binomials to look exactly the same but have a different sign in the middle, that forces these two things to cancel. So these disappear, and I'm going to be left with a 24 plus a 3, which gives me 27. And then 6 root 3 and 4 root 3 is going to be a 7 root 3, just kidding, a 10 root 3, all divided by 16 minus 3, which is 13. Awesome. Let's try another one. All right, on this problem, we are going to multiply by 1 plus root 2 over 1 plus root 2. While multiplying across, this time all we have to do is distributive property, and we get 1 plus root 2. In the denominator, we do have to do FOIL. 1 times 1 is 1. 1 times root 2 is a root 2, or you could write 1 root 2 if you wanted. And then we've got our inners, which is going to be a minus 1 root 2. And then we've got our last, which is a root 2 times a root 2, which is square root of 4, which is 2. And don't forget your negative, so that's a minus 2. Now, as I said before, we could have written this as 1 root 2, but our 1 root 2 and our minus 1 root 2 cancel, and this is always true when we're multiplying by the conjugate. So this is going to give me a 1 plus root 2, all divided by 1 minus 2, which is a negative 1. And we are done. Okay, let's try another. You might want to pause the video, try this one on your own, and see if it matches mine. All right, so you should have multiplied by 3 minus root 7 over 3 minus root 7. You can see I've multiplied them here, and then distributive property gave me this right here. The denominator is a little more complicated. You got to do FOIL. So 3 times 3 is 9, and then you've got your outer, which gives you a minus 3 root 7. Your inner gives you a positive 3 root 7, and then root 7 times negative root 7. That's going to give you minus 7. Your two inners cancel. Then you are left doing 9 minus 7, which is 2.